Hello everyone, my name's Christina and welcome to this A-Level Mathematics Calculus Series video 21. We're looking at stationary and turning points and this is part 5. So the objective for this video is just to work through an example to determine the nature of stationary points using the first and second derivative. So in this example, we want to find and determine the nature of the stationary points of f of x equals to x cubed minus 3x. So this is the function we're working with. And our first step will be to find the x-coordinates of the stationary points by solving f dash of x equals 0. So what we want to do is we want to first find the first derivative of our function f of x. So that's going to be f dash of x equals, and we're going to differentiate each individual term. So if we differentiate x cubed, we get 3x squared. If we differentiate minus 3x, we get minus 3. Make sure you're comfortable differentiating each term, and if you need a reminder, you can have a look at the previous videos on differentiating functions of x. So we now want to solve this by equating it to 0. So notice that we can first take out a factor of 3. What remains inside the brackets is x squared minus 1. Now you should recognize this as being the difference of two squares. So we can factorize it as follows. 3 bracket x minus 1 brackets x plus 1 equals 0. So that's how we would factorize this quadratic. And to solve it, we will extract our roots, which are x equals 1 and x equals minus 1. So now these correspond to the x-coordinates of our stationary points. So what we want to do next is to compute the corresponding y-coordinates for these two stationary points. So our f of x, as a reminder, is x cubed minus 3x. And so what we want to do is we want to take each of these x-coordinates, substitute it into our function here, and get the corresponding y-coordinate. So for x equals 1, we're computing f of 1, which is 1 cubed minus 3 times 1. That's equal to 1 minus 3, which is equal to minus 2. So our first stationary point, let's call that point P, is 1 minus 2. For the second stationary point, that's going to occur at x equals minus 1. We're computing f of minus 1. That's equal to minus 1 cubed minus 3 times minus 1. That's equal to minus 1 minus minus 3. So that's minus 1 plus 3. That's equal to 2. So our second stationary point, we can call it Q, is minus 1, 2. So now that we have our two stationary points here and here, we want to determine the nature of these stationary points. We will do that by finding the second derivative, f double dash of x, and then we're going to substitute our x-coordinates of our stationary points. So we're going to substitute in x equals 1 and x equals minus 1 into our second derivative function. And then we're going to look at the values we get. And then by comparing those values to what we've seen in our previous videos, we can determine if these are maximum or minimum points, or if they are neither and we have to inspect this point further. So let's start with point P. Our point P is 1 minus 2. So for this point, f double dash of x, well, we first have to find f double dash of x. So what we can do is we can either take the double derivative of our f of x, or we can just differentiate our first derivative function again. So this might be easier. So let's just differentiate this function 3x squared minus 3 because this is our first derivative. So I'll just write it here. If f dash of x is equal to 3x squared minus 3, well, f double dash of x is going to equal the differential of this expression. So let's differentiate each term. 3x squared differentiated is 6x. If you differentiate minus 3, that's just 0. So we just get 6x for the double derivative. So for point 1, 2, for our first stationary point here, f double dash of 1 is equal to 6 times 1, that's 6. So we're getting a positive value for this. We're getting our second derivative as greater than 0 for this point. Therefore, we can say P, which is the point 1 minus 2, is a minimum point. A minimum stationary point. And if you have a look back at previous videos, you should have the notes to determine this. So for the next point, for point Q, we have minus 1, 2. So we want to substitute this into our double derivative function. So f double dash of minus 1 is equal to 6 minus 1. That's minus 12. Sorry, that's not minus 12, that's minus 6. There we go. So for point Q, our double derivative function is less than 0. Therefore, we can say point Q, which is minus 1, 2, is a maximum. Stationary point. And that's an example of how you can determine the nature of stationary points using the double derivative.